Thanks. Thank you.
Okay, so right now, can we start? So everyone, can you see my screen?
Yes.
Okay, sounds good. Okay, hello everyone. Let's start. So welcome to CCAMP session. So good morning, good afternoon, good evening. Let's start from the first page. Okay, as always, let's start from the loadware information. Actually, this is the reminder about the IETF policies. And, as we know, by participating in the IETF, we have to follow IETF process and the policies, especially IPR policies. So, there are a couple of the documents about the BCP. So if anyone is new to IETF, please take a look at these documents. And this time we have only one session with 2 hours. You can get some detailed information from the link and also download some slides. So this is the agenda. This time we still have, busy agenda. Actually, we have 2 hours for this session, but we have 9 presentations, and 5 of them are about individual jobs. So maybe we can have more discussion on the especially some new jobs. So for the administrative, so actually because of the COVID-19, we are used to to having the online meeting by the Meet Echo. So I think we know how to use the this kind of online tool. And then for the minute takers, so if anyone can take some minutes, and that will be much appreciated. And I also ask Hao-Mian to help us. And I'm not sure if Oscar is joining or not. Maybe secretary is not online. Let me check. Oh, Oscar, you are here. Maybe you can help us out. And then blue sheets. So actually, the blue sheets will be created automatically, and nothing for us to do. And then we have the reminder about the IPR process. Before, for example, an individual draft becomes to a working group document, or a working group document goes to last call, the chairs will send out the IPR polling, and then it requires all of the authors and the contributors to respond to the polling as soon as possible. Otherwise, it might delay your draft to move forward. And then about the mailing list, we always encourage people to use the mailing list as much as possible. We can, for example, introduce some, discuss some open issues, or introduce some new ideas, and some new drafts on the list. And also, we may, discuss some potential new topics, relevant to the CCAMP. And also, this one important reminder is that working group consensus, it's determined on the mailing list, rather than if we got some consensus in the online meeting, and we still need to bring it to the list. Okay, Daniele, it's for you.
Yes. Next, please.
Yeah.
Okay, since the last meeting, we have two new RFCs, 1993, 1994. Both are young models. Basically, the first one is the layer 0 types, and the second one is the young data model for WSON networks. So, if I'm not mistaken, these are the first two drafts on then the first two young models on optical networks. So a big achievement. We are extremely happy about that. Next, please. We have a bunch of working group drafts being discussed today. Most of them, if not all, are young models. Basically, we have the optical impairment topology, the extension to the layer 0 types. If you currently remember, we published the layer 0 types, and immediately after that, we started working on an extension to them to include also transponders, etc. We have good progresses on the Flexigrid documents, the media channel and the young model, and the one on microwave topology. There are other working group drafts in the next slide, which are not discussed today. There are no big changes since the last meeting on them. We have the interface documents with LNP extensions and the young model for interface parameters. We have the applicability of OTN beyond 100 gigabits, but this is just this is already at a pretty advanced stage. I don't think we will see any more changes there. Next items to be, let me say, discussed for final review are related to OTN, in particular the topology and the tunnel model. And then the two drafts on client signal, the client T topology for Ethernet and the young model for client signals. Next, please. A brief update on some of them. We have the layer 1 types, which is basically define the young types for layer 1. We have minimal updates there. This is ready for to be published, to be moved forward. Working group last call has been requested. The tunnel model, this was basically waiting for the T tunnel draft in TIS, which is being progressed in these days. So we no longer have a dependency there, and we can move this forward. The draft has been updated to align with the latest updates, and we need to request for the young doctor review. Next ones. Yes, we have the layer 1 CSM. This is more keep alive. This is ready for working group last call. There is a dependency on the layer 1 types, but layer 1 types is almost there as well. The NBI applicability statement, this was last called. It has been put on hold to try to put it on a diet, as Dan said. There were some comments, and the authors were trying to reduce it a little bit because it was an extremely big document. The authors are working on an update, and which will be available soon. Next, please. And I think that's it. There is no liaison or communication incoming or outgoing since last meeting. I think we can start with the first presentation.
Okay, let's move to the first presentation. I think this might presented by Dieter or
Hello, can you hear me?
Sergio.
Hi
Yeah.
Fatai, hi Daniele.
Yes.
Hi everybody, I'm Sergio Belotti speaking from Nokia. I'm going to provide the status and update about optical impairment topology young model on behalf of the other co-authors and contributors. Next slide. Okay, we have a group that is attending weekly our meeting in which we progress the document and we are going on to have this weekly and work during this the time dedicated to that. There are from the last IETF we have provided a lot of work because we have progress both in the text of the draft in which we added section about existing the reason to know the existing OTSI signal for OMS link. We added a further section about OMS media link and the transponders part, clarifying the bidirectionality of both LTP and tunnel termination point. And we added text about geolocation information that has been provided and added also in the young part. For young model, we started to resolve the issue that was presented in the last IETF, the 83, that was regarding 3R regenerator. And with this solving the issue, we complete the 3R modeling, and then we fix it other issue on the model. Next. So this slide is just as the background for the last meeting. So we left each other in the 111 IETF with this problem. So how to associate the transceiver to provide the 3R in 3R configuration. That is a trivial case in the case of TSIG is presented just one OTSI, but is not trivial in case we have multiple OTSI. Next. So to solve the issue, we have a detailed discussion, and basically the conclusion was to base the solution of to model the connectivity considering primarily the real physical constraint and the physical constraint in the equipment at the node level. And we made 5 main assumptions. The first, for the solution, we succeed to define groups, a regenerator group created at transponder level, associating transponder in which way? The transponder are any group of transponder represent a set of transponder where there is an electrical connectivity in place, so pre-provisioning, or could be also dynamically provisioned to associate this transponder to provide the 3R regeneration. In the information related to this regenerator group, we provide also an attribute that is used for path computation to express preference between one to the group to the other. There are no constraints in the among transponder belonging to the same group. That means that any transceiver belonging to the group can be connected with any other transceiver belonging at the same group, obviously provided that you connect inbound LTP with outbound LTP. The group is basically characterized by hardware characteristics that is not provided, that is hidden at the northbound interface, and that the controller can be deduced for example, at SBI level, but not needed to provide these physical characteristics at the northbound interface. We plan to add the next version some text characterizing some specific example of configuration for these cases. Next. Okay, so basically what we made is that these are basically the two cases. So in the picture in the middle, there is example in which we have 4 transponder that is belonging at the same group, and is the case in which all the transponder is belonging. So the orange oval is representing the fact that all the 4 groups are belonging at the same hardware device. In the bottom of the picture, we have the case in which the transponder are not all belonging at the same hardware device, and we have 2 oval orange, but since the 2 groups, so the 2 device at which belonging the 2 transponder are considered as the same group, because there is an external cable that is providing connectivity. And so this is the reason of the blue oval that represent the logical group that is encompassing altogether the different transponders. So for northbound interfaces application, there is no difference between these 2 type of examples. So the full hardware device, common device, or 2 different devices belonging some transponder, but the cable that is connecting the 2. So next. Okay, so this is the solution in the YANG. So we provide the description of this regenerator group with a specific identifier for the group, the attribute considering the way of how to solve the preference in the path computation between different groups, and the pointer to the transponder that is belonging at this group. Next. Another big topic that we solve is related to the 7.2 issue. So basically, the model is providing full flexibility. Full flexibility in the sense that a tunnel termination point can host one or more transceiver that can belong also to one or more transponder. And the model does not preclude also the fact that TTP tunnel termination point can point to can be pointed to the same transponder. But as in the model, we use the construct of the local link connectivity list to express the add drop path impairments in the ROADM, while we use connectivity matrix for the express path. The issue in the local link connectivity list is that what is permitted, it is just to have one entry for any tunnel termination point LTP pair, that in our case, LTP represent the port of the add drop part of the ROADM. What we adjust with this update is that now the model is flexible enough to describe the case in which also different optical impairments are needed for transceiver that belonging at the same entry for TTP LTP in the local link connectivity list. Next slides. Here is on the left is one of the examples. Other examples are in the GitHub in the presentation that I mentioned here, the title. We have here one transponder with 4 transceivers. All the 4 transceivers are connected at the same local LTP, so the same port of the add drop part of the ROADM that we can mention nominal LTP1. So all 4 transceivers are connected to the LTP1. If we hypothesize that there are not the same impairments between the different between the 4 transceiver, so we would have 4 different set of optical impairment for each direction in one entry of the local link connectivity, while the standard definition of the local link connectivity permit only one set of for each direction. This is the problem, and to solve that, on the right part of the picture, we introduced a list of possible transceiver with, let me say, differentiation with respect to the default. That this list has to be added in the local link connectivity entry, and for any part of in any element of this list, you can add specific path impairments, optical impairments, specifying detail for this specific transceiver. And this solves the issue, so you can have one entry, but in the entry we can specify different impairments in the case you needed for any transceiver. Next. Okay, here I added basic other issue that we solve with the enhancement in the model. So we added the information regarding geolocation of amplifier. And we added the possibility to identify OTSI in reverse direction. Next. We added also in the model the possibility in the for any OMS to associate any in the OMS link to associate a unidirectional link in case of a parallel link between two nodes. So to associate one link to the other to understand that belong at the same OMS part, and to associate also the OMS element in the reverse direction. For example, the same amplifier in the direction in the both direction related to a bidirectional part of the OMS. Next. So here I provided the situation of the open issue. We have you can see the link to our GitHub in which is provided discussion and situation of the issue. We solve 12 issue after IETF 111, and we have still 16 open issue. But for the moment, we have just 2 pending young model enhancement that we still need to add. And basically, we have 5 review terminology that is still needed. And this anyway is the situation of any issue that is still remain in the drafts. Next. So next step, obviously we wanted to address the issue that remain open. Both regarding the enhancement that we need to have that at the moment are 2 issues regarding the model and the editorial part. We would like to be ready for young doctor review and we hope to have the possibility to have a stable version. I mean, and for stable version means to have a model that is supporting all the basic features that we consider and an alignment in the terminology. And this we hope by next IETF that we hope that it could be also in person, but let's see. Okay.
Okay, any comments? Oh, there's just one slide about backup. Oh,
okay. This is.
Would you like to introduce the backup slide?
No, this is backup just to provide again the picture related to the reference configuration for 3R and the usage of the other slide, the local link connectivity that, as I said, is used to provide add drop impairments in the case of for RODAM. So this is just as reference in the case you need clarification.
Okay, thank you, Sergio. Any comments? Let me return back to the, yeah. No comments. So I have just one minor comment from my side. So regarding the next step, since there are still, a couple of open issues to be fixed. So I would kindly suggest we send this draft for young doctor review once these open issues are fixed. Is that okay for you?
Yes. Yeah, at least, well, for young doctor review, the needed is that to fix the young part. So I suppose that this can be, can be feasible in a good time frame.
Okay, thank you. Yeah. Any other comments from the floor? None? Okay, good. And then let's move to the presentation 2. Okay, it's still for you, Sergio?
Yes. Okay.
Okay.
I'm going also to present the update for the layer 0 type extension that, as said before by Daniele, is representing the layer 0 extension, providing all the information related to the transponder part that has been put out of the layer 0 type now that is became RFC. Next slide. This draft was adopted as a working group draft in August and was submitted as 0.0 version. The update that we provide this time is basically related to an issue that is coming from optical impairment topology model, that is the issue 42 regarding the minimum channel spacing parameters. This issue is brought together some modification in the layer 0 type extension. So we need to remove the OTSI carrier bandwidth and Nyquist spacing factor. We added the new definition of minimum carrier spacing, and we clarify names and description of some parameters, the minimum central frequency, max central frequency, and central frequency step, to be aligned with the text that is provided in the section 2.5, 2.4 of the optical impairment drafts. So this is basically the update. Next. For next step, we need to add other young structure as needed, always with the intent of sharing the same young structure among different layer 0 young model in CCAMP, and waiting to incorporate the update from the layer 0 type now that has been published as RFC 9093, as we provide and we foreseen in the basic plan for the layer 0 type extension. So to incorporate immediately the update that is coming from layer 0 type as soon as it became RFC. I finish from my side.
Okay, thank you, Sergio. So any comments?
Welcome.
No comments? So if there's no comments from the floor, I have one. Okay, please.
Yeah, certainly. I'm trying to help, but I would like to clarify regarding the layer 0 types extension. What is the expectation of this basic model supporting the other documents? For example, we understand that it will be supporting the optical impairment topology Young module. Do we have other modules besides this? For example, the Flexigrid Young topology or others?
Oh man, I don't know if it's just my problem, but your voice is up and down, and so I didn't get your question, frankly speaking.
Oh, let me repeat and try again. The question is, what is a target document for the layer 0 type extension?
I mean, we cannot hear you clearly.
Hello?
Oh, maybe the connectivity is not good. So let me ask one more comment. So at the next step, the second says, this draft or FCV2 2B will incorporate updates from FC V1 or layer 0 types. So for me, it seems that FCV1 will be obsoleted by FCV2, right? Rather than just updated by FC V2. So I mean, so we would like to. I think we should think about which category either update or obsolete should be used. If FC V2 obsolete FC V1, then the document's relationship should also be reflected like this page backup, information. So I think maybe we should, have more investigation and think about which kind of category to be used.
Okay, you mean category related to what type of draft name? This is what you're saying.
Yeah. Right. And
yeah,
you can look at one draft, FC 2223. In this draft, it defines the terminologies on update and obsolete. So maybe we can also get some, input or feedback from agent, because I think he knows more things than us.
Sure. Yeah. So the intent at the end, you remember, is that we should have, let me say, version 2 of layer 0 type RFC that incorporate everything. This is the last step. As soon as, if you look at my background backup slides of the presentation, that there was the famous flow of information. The last step should be these ones that layer 0 type extension has incorporate all the update from layer 0 type as today, in the sense that is became RFC. This is the intention.
Okay. But in the FC 2223, it defines the update and the obsolete for the updates, it says to be used as a reference from a new item that cannot be used alone to reference the previous document. But for the obsolete, it says to be used to reference to an early document that is replaced by this document. So if your intention is to incorporate updates from the layer 0 types, which means that RCV2 will cover everything from the layer 2 types, So I mean, so in this way, maybe we can think about if we should use the update or obsolete.
Fatai?
Yeah. Please, yeah.
Am I allowed to speak?
Yeah.
Thank you.
We can hear.
Yeah, my understanding is actually that the Yang model extensions we're currently defining are actually adding to the existing layer 0 types, which are published in RFC 1993 now. And in my opinion, if the new model with the extensions will be published, that should actually replace the old or the previous version of layer 0 types. That means that it obsoletes that RFC 1993. That's my opinion.
Okay. Yeah, it's also my understanding. Yeah. So if data and my understanding is correct, and then we should change the category of the RFC, and we should use the obsolete rather than the update. Maybe we can double check anyway, right? Yeah.
Sure.
Okay. Okay, any other comments?
Yes, hi. Just a quick comment on the next steps when designing the layer 0 types extension groupings. We should also keep in mind that it needs to support other models like the tunnel models, as well as new models like optical path computation. Basically, all the groupings needs to be carefully designed to allow sharing between different models.
Okay. Let's move to the present. So, Sergio, are you going to respond?
No, I agree in the sense that surely the intention of the draft is clear. It's to host a common structure that can be used by different layer 0 model, Yang model. So yeah, if there is other draft that is coming, it's true that the document has to be used in the context also of these new drafts.
Okay. Yeah. Thank you, Sergio.
Maybe Italo wanted to. Italo is the KU.
Italo, please.
Quick comment. I think if you want to make it clear that we are replacing 1993, what we can do now is we can restructure the draft as being a 1993 bis draft and rename the draft as well, so we can make it more clear that that's where we are going.
Yeah. Okay.
Okay.
Okay. Thank you. Let's move to presentation 3. Flexigrid Yang models. Mr. Dan.
Hi guys.
Yeah.
Hi, Mr. Hi. You can hear me okay? Excellent. Yeah. So thanks guys. Just a short update on our Flexigrid efforts. You might have seen some emails to the CCAMP list earlier today. That was me submitting a new document. So one of the things that we've been sort of doing with our Flexigrid work is trying to harmonize some of our naming. And one thing that we noticed with the previous media channel document, so that was the Yang data model for Flexigrid media channels, is that wasn't a sort of consistent name with some of the other documents in CCAMP, such as the WSON tunnel document. So we just updated the name, and it was sort of dependent actually on the chairs just authorizing that this new document, a Yang data model for Flexigrid tunnels, replaces the document, a Yang data model for Flexigrid media channels. So sorry if you just saw that email earlier, but that's the change. Next slide, please. Cool. So the first document that I'm briefly going to talk about is our sort of optical topology document for Flexigrid networks. This is now in its version 11 incarnation, and this was the document that was submitted a couple of hours ago, and it now points to our new tunnel document. And we've also updated the terminology within the document, so essentially sort of replacing media channel with tunnel, although we do explain what a tunnel is. In fact, it is a media channel. We have addressed just a few sort of open issues since the last IETF, but essentially it's now stable. The code is stable. It is ready for sort of a review from the working group. So we would like to enter this document into working group last call. You may have thought that it's had a Yang doctor review, which it has. That was an early review. So we will now hope that the working group is ready to kind of take a look at this and let us know if there's anything obvious or major that needs to be addressed. Otherwise, we can sort of progress this through the IESG and the sort of the RFC process. Next slide, please. So we're now going to focus on our tunnel document. This is typically something that we talk about on a weekly call, and I've posted the call details to the mailing list. They are also available, I think, at the end of the slide deck that we've got today, so anyone is welcome. When we have sort of substantive points that we want to raise, or there are specific options that we need to agree or discard, we will take these to the list. So don't think of these kind of calls that we're having as sort of circumnavigating working group process. We will absolutely liaise with the working group when it comes to sort of making key decisions and post those to the list or obviously highlight them during our presentations. What's changed in our most recent document? I hear you cry. Well, we've updated the prefix now. Again, that was an ongoing discussion that we had sort of prior really to IETF111, and it sort of just bled over post IETF111. So those have been updated. You will notice as well, if you've checked out the current code of the document, that we've ripped out the RPC function for the path computation, specifically for Flexigrid. In this case, that is now a new document and a new piece of code, which will be discussed a little bit later today, I think. Now, we found actually that this was, I think, a useful exercise. And I'm sure Iwa or Italo will explain that sort of rationale a little bit later. There has been some sort of minor code changes as well, just sort of fixing some compilation errors, because we're heavily dependent, of course, on some of the other documents that the CCAMP group are working on. Things like, gosh, what do we? Yeah, so the Yang TE model, the topology model. and so on and so forth. In fact, it's probably the Flexigrid topology document as well is kind of linked to things like impairment topology as well. So there are a lot of dependencies between these documents. When something changes, if it affects us, then of course we need to update that as well. Next slide, please. So what would we like sort of the working group to consider, potentially help with? Well, we've sort of narrowed some of the discussion and the applicability, really the scope of how we're going to use this model and what we're using it for. So this is kind of really important for next generation optical technology. It's not designed for some of the legacy optical equipment. So we've sort of clarified that now in the document. There are sort of ongoing discussions with things like sort of operational issues, specifically the OTSI and how that's actually used for sort of setting up our tunnels. I think, of course, the OTSI issues being raised in some of the other IDs as well. So we've kind of linked the OTSI discussion from those other conversations with, and that's specifically, I think, the impairment topology document. So we've linked that with our Flexigrid tunnel document. We found actually it's useful to have, it was one of the review sort of observations that we had when we had a sort of routing area review of another document, that it's good to explain how this model is used in the context of other models, and just as sort of early in the document, rather than having to kind of delve into the YAN code itself to see what's augmented or extended. We just explain at a high level very early in the document. There are actually sort of more open issues, on the order of probably sort of 10 open issues, including things like simple things, in theory at least. We've got too many document authors. In fact, it's really anyone who showed any kind of interest and actually commented or provided text has been included as an author, which meant we've gone beyond the recommended or mandated number. So that needs to be resolved as well. And you can find all of these open issues on our sort of CCAMP GitHub repository, which I will talk to Dieter. I think we will need to change now because it refers to media channel rather than sort of Flexigrid tunnel. I think that's an easy change that we can do within GitHub. Next slide, please. So finally, the sort of another observation that was made on our recent call is, well, we've got the Flexigrid topology. So great, I can export information about my Flexigrid transport network from sort of my physical devices. We've got our optical inventory document as well. So there's potentially additional information that's not online or available to be queried, or things that are online but aren't sort of distributed in the traffic engineering database. We've got the Flexigrid media channel document and model for actually setting up the connection. But what about things like sort of operational aspects? And this is it's kind of interesting, because in the IETF we always get excited about sort of new technology, control plane or forwarding behavior, or at least how to set that up and manage it. We often sort of think about the operational and even some of the security aspects as kind of a bit of an afterthought, although we are supposed to have sections specifically that sort of cover these. So I've just raised an issue within GitHub. Just something we need to be thinking about is, if we set up our Flexigrid transport network, what about once we've got our connections set up as well, how do we monitor them? How do we troubleshoot them? And yes, I know that we've got other documents within CCAMP which aren't actually being presented in this session, so I'll follow up with the authors. So there are things like the optical interface parameters document. There are the client signal and performance monitoring document as well. And I'm just kind of mindful that maybe we need to be looking at these and thinking about some of this work and its context of Flexigrid as well, and making sure that we're actually able to not only set up our infrastructure, create services, but actually monitor and manage those services as well. So that's another sort of area we'll be investigating. Thank you. I think that's everything I wanted to say. Next slide. Oh, there's maybe another slide.
This is the last one.
No, okay, I lied. I deleted it. Great.
Okay.
Any questions?
Yeah, thank you, Dan. Any questions? Any comments? No comments, no question?
No, nothing. No one's awake.
Yeah. I think for the first document, which is about the Flexigrid topology, I think it's quite stable, right? And so maybe we can think about, move forward this draft.
Yes, please.
Yeah.
Oh,
okay.
Hao-Mian is Hao-Mian put his hand up?
Hao-Mian?
This time?
Yes, we can hear you, Hao-Mian.
Yeah, I'm trying to clarify a little bit about the last page when you talk about the side discussion on operational aspects. This would be greatly appreciated and needed, but I believe this is not needed only for Flexigrid networks. So I'm trying to understand: are we putting the same functionality, for example, performance monitoring for every kind of potential networks, or we are doing this per switching technology? So I would rather prefer doing this together instead of only discussing with the Flexigrid.
Yes, that is actually a really good point, and I kind of feel the presence of Lou Berger here as well, saying don't make this technology specific. This can be generalized and applied to multiple technologies. We can save time and people's effort. So that's a really good point. I'll definitely do that where possible.
Okay, yeah, thank you. So let's move to next. Microwave. I think this is for Scott.
Yes, hi, is voice check here?
Yeah.
Yep, it looks like I'm coming through. I see the little graph that my voice is coming through. So welcome, thanks, chairs, and welcome to the CCAMP working group. This is the first time you've heard about this one in a while, so we felt that it was time to provide a update on the microwave topology Yang data model. There is a version 2 draft that's available, and you can see a couple links there. One's to the data tracker and one's to our brand new GitHub that we're trying to migrate to so we can track issues and those types of things. So you can also see the authors on this page too. So go to this next slide, please. So I'll take you through some of the things that we've done. So our status is that we've separated the modeling out, so we now have modeling of radio links and carriers as separate link entities. That was something that was modified since version 1. And then we also have added a couple of additional modules. So our draft has a topology module in it that is an extension of the TE topology model, and the IETF TE topology model. And then in order to make it even more generic, we separated out bandwidth availability as a separate augmentation, and also how the traffic engineer, or how the microwave model can be linked back to interfaces. And so that's a separate module and augmentation as well. So if you just want microwave topology modeling, you can use one of the modules. If you need bandwidth availability, you can add that one. And if you want to link it to a interface in a IETF stance, you can use the interface topology. So we wanted to bring this up as something that we're working on and see if there are others that like this kind of separation and modularization. So going on to the next slide, we'll get into some of the more details around. Next slide. Can you hear me? Hello? Hello?
We can hear you, Scott.
I need to go to the next slide. Have they switched slides? Because I don't see a slide has been changed. I'm still on the status.
Yeah.
I'm sorry?
Yeah, I hear you, and it sounds like other people hear you, but maybe Fatai doesn't hear you. Fatai, are you
Maybe, because that seems to be the, so maybe I should just put next slide in the chat window. How about that? Yeah, I think that might be the issue.
Anybody know if there's a
Yeah, it says
screen sharing is frozen.
Screen sharing is frozen.
And the screen is gone, at least from
He
my
dropped.
point of view.
Okay, so do you want me to, I can download my presentation.
I received a call from Fatai. He is rejoining. But
okay.
I don't know, Scott, if you can share the screen without the authentication from the chair.
Well, let's see. I can. I don't know if I can or not. So I can try. Is there a?
I mean, we could all click along on the meeting materials, but that's pretty clunky.
Right. So ask
Daniele,
to share
are you
slides.
there?
That one, yeah.
Yes, I'm here.
Are you able to either share the slides or authorize Scott to share his screen?
Yeah, let me bring.
Ask for permission. I'll allow you.
Okay, let me download my slides real quick. Okay, all right. So if I click on that.
You just raised your hand, but did you
Did
click
I?
on the?
I clicked on the thing next to my hand.
Okay, well, you also showed up in the queue, but.
Oh, well, yeah. Well, interesting. System viewer. Okay, I have. I have something I can share if we're ready. Am I allowed? Do I just do presentation view? Maybe.
Daniele, do you need to do anything else on your end, or I do see Scott's sharing request there.
I think so, but I don't see any request.
Oh, well, I'll cancel it and try again.
Let's see.
There, I clicked on the.
Okay, grant.
There it is. Okay. Deck's ready to share. So I want to.
How many engineers?
Nice. So what number is mine? 4. This one. Ooh, share. Oh, look at that. Now, I was having some trouble with my voice breaking up when I was displaying slides before. Am I still coming through?
Yes.
Okay, perfect. All right. So next slide is, I already did that one. So next slide. So these are the new generic modules. I wanted to provide a little more detail on this to make it easier to see. So there is a bandwidth availability topology module in this Yang file, and then there's also a interface reference topology, and you can see the augmentation I stole from the tree, how it adds, the capabilities for a bandwidth availability, and it extends the TE topology model. And then the same, and then for the interface, we're extending the, we're adding the interface name to the termination point. So that allows us to have our reference to the interface that's being used for that particular piece of the topology. So that's two generic modules, might be useful for other people if they like that sort of thing. So based on our recommendations from TEAS, we're now basing our module, and I know this is an eye chart, so you can click on them and zoom in on them if you really want to see the trees. One of the original versions of the microwave topology model inherited from or augmented the IETF network topology. And so we looked at the IETF TE topology module and thought it was complex because of how big and overwhelming it was, but come to find out, it wasn't so complex because we had people like Talo and others on the call being able to take us through how most of the IETF TE topology as described in 8795 was designed to be optional and also agnostic and to support augmentation everywhere. So and the TE topology module, just as an editorial, it really isn't just about TE. It's really a set of tools that you can use to augment topology, and you get the benefit of network topology, you get the benefit of traffic engineering, and you get the benefit of GIS stuff. So there's various things in that module that are useful, and the way that it's written, it's very easy to take and modify and use only what you need. So we created these three augmentations, augmentation of TE topology, an augmentation of termination point, and an augmentation of TE link attributes. So we have an example. So one thing that we're trying to do is we're trying to leverage some of the tools like YangLint and tools like that to test that our model works and that the must statements and XPaths and all that stuff are right. So we created an XML example that we then run through YangLint and produce a JSON example, and to validate that what we're doing hangs together correctly. So this is a pretty picture of an ASCII art picture that's in the draft that shows what we've done in that. So we have a couple nodes and a couple of RLTPs and some CTPs, and you'll see the instance diagrams and the instance information in JSON in the draft and in the A.2. So I wanted to provide that just to show that, and we can use it for regression testing and also to test our use cases and such. So what's our way forward? Our way forward is we have, and I saw and I felt bad because Dan King had an excellent point on his slides. He said when his meetings were, the thing I forgot to put in here is that we do have meetings every Wednesday at 11 a.m. Central European time to discuss this with microwave experts. So if you're interested in joining that, we share our status on the mailing list. And one thing that we're trying to do now is get everybody over to using our GitHub and get the issues list in there. We're also right now trying to convert over to using Markdown so that we can generate the draft and using some of the more modern tools. And then we want to add some more JSON examples. We find those to be very useful in our discussions to make sure that we have everything covered. And there's also some microwave related expertise and questions that we want to make sure that we have all of the right microwave knobs and buttons and dials that we need in our topology module. So we're asking for feedback from the working group and appreciate your time. Thanks. think that was my last one. Yeah. So I'll turn it back over to Fatai, or I'm not hearing anybody talk. So, I mean, if nobody else talks, I will continue to talk. There we go. There, I'll do that.
Thank you. Yeah. Any comments? No comments?
I appreciate your time.
Good.
Thank you very much. Bye.
Yeah, thank you, Scott. Yeah. So we have done the the working group the presentations on the working group documents, and then let's move to the second half of the session, which about the individual jobs. Next one, which is slicing, right? Hi, Hua.
Yes, can you hear me?
Okay, yeah, go ahead.
Good. Yeah, so my name is Aihua Guo, and I'm presenting this draft for OTN network slicing on behalf of all the authors and co-authors. Next slide. Okay, so here are some major updates since the last revision. We have an expanded list of authors and contributors, and we're welcoming Shifeng and Jiang from China Mobile to join us. And over the last couple of months, we have had some good alignment with the TEAS network slice. In particular, all the discussions within TEAS working group on terminologies and definitions on, for example, endpoints and connectivity matrices. These also are reflected in our thoughts towards building up the YAM model for northbound interface. So with this revision, we also added text to describe the design of the YAM model for the OTN slicing controller NBI, and as well as an initial revision of the northbound interface YAM model, in which we try to propose a common model that could be used for transport network slicing that can support different transport network technologies. And this draft also includes a minor updates to the NPI YAM model, and the details will be on the next few slides. Next. Okay, so for the OTN slice controller NPI modeling, our thoughts is to build the NPI modeling on a common model, which is technology agnostic, and importantly to support both connectivity-based slices as well as a resource-based slicing. By using this model, it allows a user to use connectivity matrix to express the intended connectivity between the endpoints. But also, at the same time, it could use a topology, a network topology, to express the reservation of resources within the network for a particular slice, and also can express the detailed path across the network topology. And basically, it supports a mode such that the resources could be reserved with the slice, and then the connection could be instantiated over the slice as the customer needs at a later time. So with the common model, we expect it, like I said, to support slicing for any layer of transport technologies, including, for example, OTN, WDM, as well as MPLS-TP. Right? And then the OTN slice MBI is just built on the common model with OTN-specific arguments. And within the design of this MBI model, we try to reuse concepts and model fragments from existing drafts from both TEAS and from the TEAS group. There are a few candidates we have looked at. The draft Liu network transport network slice YAN, which defines a network topology for resource-based slicing, and with also a list of technology agnostic SLO attributes, and the ACTM YAN model from TEAS, which is a CMI model that that offers the support for both type 1 and type 2, as is written in the draft, which corresponds to connectivity-based as well as resource-based virtual networks. And the only thing is this model is much entangled with ACTN and the traffic engineering T topology, which we are trying to make it more generic, and so this there are some support which we imported from the ACTM YAN. And the last one is actually the TEAS working group draft, which was just adopted for the network slice MBI. It has a common definition for endpoints and SLOs, but the drawback is it only supports connectivity-based slicing, and a lot of the attributes in there is IP technology specific, which does not apply to transport slicing. So yeah, so those are the reference drafts that we have looked at when designing the common YAN model for OTN slice MPI. Next page. Yeah, so this is an overview of the YAN tree for the common model for transport network slicing. As you can see in the model, we have a network slice has SLO attributes, endpoints, network topology, which could be used to describe a detailed network topology on which the network slice is built on, and a list of connectivity matrices that much resembles what is in the IETF in the TEAS network slicing draft. Next page. Yeah, there is a minor update to the MPI YAN model proposed before, in which we added a choice statement which allows a resource to be colored based on either the number of time slots, OTN time slots, or a list of ODU containers based on the type of the container. Next page. Okay, so some open issues. First thing is when we are designing the MBI YAN model, as we said, we're trying to reuse as much possible, as possible the existing models. And one of the options is to look into the schema mount and try to include model fragments from let's say draft Liu network topology and put it underneath the network topology subtree of the common NBI-YANG. Now, the issue we are seeing is what we are trying to do is to do a design time schema mount without redefining the models. However, the current schema mount only supports runtime and implementation time, which is not necessarily what we are looking at. And also the schema mount is currently missing some support and toolchain support, which we could use for validation. Whether we could use a schema mount remains an open issue, and we need some further investigation as well as examples to understand how it could be used. Yeah. And another open issue is to whether to model a connectivity matrix as a topology, basically as a single node topology, or as a list of intended connections, as we currently put in the model. I think this is also a question to the TEAS network slicing model as well. This is just two different options, and so we put the connectivity, a list of connections as our initial choice, but it remains open as to what we go for next. Okay, next page. Yeah, so next steps, we will be continuously developing OTN augmentation based on the common transport network slice model. And we need to also support the slicing for non-OTN links, external links, which is attached to the OTN network. And there are a couple of open issues in the GitHub that we have we are looking at, and also comments and reviews from the working group. As for the status of the draft, the authors actually believe the draft is ready for working group adoption because of the good interest we have seen and a good list of participants in the discussion. And we have models proposed, and I believe the work can be kept working on with the working group document. And we have asked for the working group adoption before the meeting. So the weekly discussion, we have a weekly discussion set up and on Thursday, 10 to 11 a.m. Eastern time. And the GitHub is also listed here. So anyone interested in this work is more than welcome to join us. Thank you. I think this is the last page. Any questions or comments?
Okay, thank you, Anhua. Any comments or questions? No questions? No comments? It seems that all the participants are very nice this evening. This meeting, right? In China, we are evening.
Yeah, I think many interested parties, participants are already in our weekly discussion. So the steps are clear. Hope we could have more comments from the working group.
Hao-Mian?
Most of the issues are under discussion on the weekly call, and I think we reached good consensus. Just one more comment talking about the schema amount. I think such kind of evaluation is not slicing specific, and there should be a generic question to all the modules. So I would rather suggest we focus on the slicing itself and those kind of schema amount or whatever young grammar level stuffs can be discussed in more general or work with more young experts instead of the slicing itself. Thank you.
Okay, thank you.
Yeah, I'm just to quickly respond to Hao-Mian's comments. Yes, I agree with you, and I think the use of schema mount is just a tool to facilitate the design of the model. It shouldn't stop us from moving forward. The worst case is just we have to copy paste some of the definitions, but yeah, that's not a showstopper.
Okay, thank you. Yeah, I think actually, the slicing topic is quite interesting and sexy, right? So, and also I think this draft is organized very well. So I would like to poll to test the temperature. So how many people think that this draft is ready for WG adoption? If you support, please type +1 in the chat window. Otherwise, if you object, please type -1. Yeah, let me see. Okay. Are you all done? Yeah. Okay. Yeah. I say many people support WG adoption. No one objects. So let's take on the list. Thank you, Aihua. Yeah. Let me move to the next. Italo, please.
Thank you, Mr. Chairman. Okay, I'm presenting a new draft for requesting power computation optical networks. Next slide on behalf of co-authors. Next slide, please, and contributors. Okay, what is the problem that we are trying to solve? Is a problem when we have an optical network, which can be a WZone network, a Flexigrid network, or even OTN network, and we would like to request via an RPC the optical network controller to perform path computation over the optical network. There is a draft in this working group which describes what are the generic requirements and use case for an RPC to request path computation over any type of transport engineering network, traffic engineering network, and the optical networks are mentioned as examples of networks which will benefit for such an RPC. The model that is defined in the TIS working group is a generic and technology agnostic model, which is developed in alignment with the T-tunnel model also developed in TIS. What is missing from the work in TIS is just a set of technology-specific attributes which are specific to the optical networks like WZone, Flexigrid, and OTN. So what does this model is simply taking the generic model developed in TIS and reusing the common definition in layer 0 types, layer 0 type extension, and layer 1 types, and augment the generic tunnel, the path computation model with these attributes for technology-specific labels or for technology-specific bandwidth definitions and so on. And by being based on the generic path computation model, it's also aligned with the tunnel models for the optical network. So you can use the path computation model to request a path computation and then the tunnel model to set it up. The lack of these technology-specific attributes was also identified during the analysis in the POI, ACTM POI. We noticed that if you wish to request an optical network controller to perform a path computation in optical network, you miss the information about the technology-specific attributes of the optical network. Next slide. So as I said, the contribution, the draft is very simple. It's just augmenting. There are a few open issues. Maybe it's worthwhile to discuss. The one open issue is a little bit much bigger scope than our draft. Is the fact that we are reusing the layer 0 tunnel attributes and layer 0 path constraints groupings, which are defined in layer 0 type extensions. But there are the attributes in this grouping needs to be validated, and we already have 2 open issues in the tunnel in the GitHub for the Flexigrid tunnel, and we think that this an issue is equally applicable to all the drafts which are using these 2 groupings. And my suggestion is to address this issue jointly with the other drafts. And second issue is more organizational, whether we want to keep all these 3 modules into one document or to split into 2 or 3 documents and follow the same structure as in the tunnel model. So whether we want to have 3 documents, one for WZone, one for Flexigrid, and one for OTN, or any other combination. Or maybe we can focus the discussion on these 2 open issues. And the next steps is basically any comment or feedbacks. Oh, okay. From the working group, we will address, and please review and comment. We would like to finalize what is the structure of the document, so whether to have to progress 1 document, 2 documents, or 3 documents. And then after we have finalized the document structure, I think we could request working group adoption, because we think that this is a draft that complements the current tool set of working group, of CCAMP working group technology specific models, which augments the generic T models developed in TIS for optical networks, and the work is quite straightforward because we reuse definitions, common definitions, which are already available in the other drafts developed in the RSC in 1993 and the other 2 drafts developed by CCAMP. Thank you.
Okay, thank you, Italo. Any comments? Dieter, yeah, please.
Who is first?
Yeah.
Go, Dieter.
Yeah, I think it makes sense to actually have cover the WSON and the Flexigrid in one draft, because both belong to layer 0, whereas layer 1 could be done in a separate draft.
One question, Dieter. Do you mean one draft with 2 YAM modules?
Yeah, I mean, they could be organized in yeah, 2 different modules.
Okay. Okay, good. Yep.
Okay. Hua.
Typing. Yeah, I share the same comments as Dieter.
Okay, thank you. Okay, any more comments? So I think from my perspective, I think regarding 1 document versus 3 documents, if there's no any fundamental difference, and then I think we can just keep one in one document, right? If the document is not much big, and this will be an easy way to just document the three models in just one single document. Is that okay for you, Italo?
I don't have any strong opinion on the number of documents. I'm okay with 1, 2, or 3.
Okay, and then maybe we can also
before working group adoption, I think we need to decide how many documents we want to develop.
Okay, but regarding the WG adoption, I think maybe we can have one more revision and then decide if it's ready for WG adoption or not.
Okay.
It's okay.
Okay.
Yeah. Okay. Thank you. Let's move to next one. Inventory. Okay, Chao.
Okay, thank you, Chair.
Hi.
Hello, everyone. Yeah. Okay, nice to meet you here today. Okay, my name is Yu Chaode. I'm from Huawei Company. Our job is a young data model for optical network inventory. I'm presenting on behalf of all authors and contributors. This young model will be used in the northbound of network controller. Okay, please go to the next page. Okay, in the first page, we describe the motivation of this job. Let's have a look why this model is needed. The first two motivations can be described by the figure below. Okay, let's see. The operation and management system of operators consists of various OSS. The resource management OSS, which is in red and in the middle of this figure, is playing a very important role. It collects inventory data from network control and provide resource validation, resource mapping, and resource retrieval functionality for the other OSS system. But the inventory data stored in the resource management OSS system is usually collected by some private protocols like COBA, XML, and RESTful. And for RESTCOM interface, we just find one hardware data model in RFC 8348, which is considered to be used to do hardware management on a single network element, and it cannot provide a network level management interface. So we consider that there is a need for network inventory young model. So far, we have designed this model based on the inventory of optical network. And this model are probably also applicable to other technology like IP and microwave. It can be technology agnostic. Okay, please go to the next page. We investigate on the existing data model in IETF and clarify the model relationship in this page. According to RFC 8345, the inventory data model could be augmentation of abstract network model. But considering the complexity of the existing topology model, and some applications only want to retrieve inventory, so if we augment the inventory model, augment the network model, some more filtering step will be required, and some unnecessary misunderstanding will be made. So, and also the integration difficulty will get worse in a large scale of network. So we propose to have an independent route for the inventory model, just like the figure in option 2 shows. With a new route, the retrieval of inventory data can be acquired in a single step and without filtering. Okay, please go to the next page. And for RFC 8348, so it is a never element level, but we think its generic modeling idea will be good for our model being adopted by other technology. In this hardware model of the objects in never element can be defined as a component, and they can be distinguished by their classes. If our inventory model will use this component idea and also some common attributes, it will help adoption and in other technology. But for inventory model, we only focus on the state data. All the configuration data in RFC 8348 will not be taken into consideration. Besides, with the schema technology defined in RFC 8528, there could be the possibility that the hardware model data can be added to some other young models. If a vendor has implemented the hardware model, he can add the hardware model data to the network model to provide inventory information instead. But schema amount is still under investigation because not too much example has been found right now. Okay, please go to the next page. In this page, we provide all the inventory object and their relationship. Just like the figure shows, the inventory objects contain equipment room, rack, network element, shelf, slot or subslot, board, and post. In real network, a rack can be deployed with several network elements, and a network element can also be installed on different racks. So there are no parent to child relationship. The same situation is also happening between slot and board. These are the special scenario we need to consider when we specify the inventory model. Okay, please go to the next page. Okay, here's the young model we provide in this draft. It follows the young model follows the relationship we draw in the last page, and we just define a simple inventory model without a lot of detailed information. This information will be specified in future step by step. And you can also see that we have reused the component idea as RFC 8348. A component list is defined under the network element node. And to support the one network element installed on different rack scenario, the rack is not defined as a component of network element. But the shelf in rack can refer to shelf component in network element. Okay, please go to the next page. In current world, we focus on optical inventory model and receive good support from CCAMP experts. Since the model may also be applicable to a wider scope, we will report our progress to other working groups continually, such as the NetMod and OPS AWG. And we think that there is also large room for discussion that whether the inventory model augments RFC 8345 or not. So as the schema among technology, do we need to take it into consideration when it is not widely supported in young ecosystems? Okay, that's all for my presentation. We also create a repository in GitHub, and we are looking forward to your comments, feedback, and we are also open to collaboration. Thank you.
Okay, thank you, Todd. Any questions? Questions are welcome. Any questions? no questions? So I would like to ask, okay, Italo.
It's an open question about whether, okay, the draft, as we plan to make the draft more generic, and it's good to clarify that this is the working group where we will continue or not.
We suggest to continue this job in. Okay. We suggest to continue to this job in our CCAMP group. Okay, and for the other group, we will report our progress to them, and whether it will be adopted by the other working group is up to them. Okay. Yeah.
So actually, I think we could get some advice from our AD John. Yeah, please, John.
Yeah.
Wondering about the same thing. I mean, it seems like for the moment, continuing it here and discussing it in the other working groups is probably the right thing to do. Hopefully we can have something a little firmer before that we come around to the next IETF, presumably in discussion with the chairs of those other groups.
Okay, thank you very much.
I don't have a problem with proceeding here for now.
Okay, thank you. Yeah, good. Any other comments? We got
okay. So yeah.
From them.
Ipr here, just a quick comment. I think, like, I agree we could continue this work in the CCAMP working group, but the name of the draft contains optical, I think, which is a bit too constraining. Maybe we could make it more like a network inventory. So in the future, you know, if we make it more generic and have it in other working groups, that could be done easily. Otherwise, if we make it like optical, we are constraining only to the optical inventory.
Yeah. Okay.
Okay, thank you, guys. Yeah, and also Duncan said he will, send a question to the list. Thank you, Dan. Let's move to next. Cloud to optic to cloud. Okay, Sun.
Sure. Yeah. Can you hear me?
Yeah.
Thank you. Thank you. Hello, everyone. This draft is from China Mobile and Huawei Technology. I'm Shen Liu from China Mobile, and I will give a presentation on accessing cloud via optical network problem statement. Next page, please. So the first slide talks about the motivation of this work. As cloud-based applications are growing in popularity, data center and the data center interconnection are becoming increasingly important. For example, finance service need a low latency, high reliability connection. Government service need a large bandwidth and high security connection. Medicine may need large bandwidth and high reliability, and internet company may need large bandwidth and low latency. So previously, users access cloud mainly with IP networks. But currently, we believe accessing cloud with optical networks is increasingly attractive and becoming an option for the users. Since optical networks is based on TDM, time division multiplexing technologies, so it doesn't have queuing issues and can perfectly avoid patches congestion and something like that. So we think this the reason we think is suitable for accessing cloud. Next slide, please. So I will give several use cases for optical network accessing cloud. The first use case is multi-cloud accessing. So basically, cloud services are usually supported by multiple interconnected data center, which are spaced within one region, normally within 1 kilometer. The reason to spacing within 1 kilometer is like that. The cloud service usually need to support ITU to ITU storage or virtual machine services and some services of this kind. So the distance should be not too far. So the cloud service have the demand of, for example, on-demand services, scalability, high availability, and user-based building, etc. This raises the requirement for data center interconnection, like large capacity, low latency, reliability, and flexible scheduling, etc. We believe advanced optical transport network is ideal for this data center interconnection applications. For example, we can use VPN to connect the multiple cloud, and we use ODUK as the tunnels in between to connect this cloud. Perhaps we also can use smart management and control system for the traffic perception. So next page, please. The second use case is a high quality leased LAN. A high quality private LAN provide large bandwidth, low latency, high security, and reliability. With optical networks, actually we can have all this kind of attributes. Users can move their core asset to cloud side, and the operator can with this optical network to access cloud. Operator can accelerate the deployment of the cloud services and reduce CapEx, OpEx. Next slide, please. And the third use case is cloud virtual reality. As we know that user experience of virtual reality is mainly depends on the local dedicated hardware for rendering. If we move the rendering resources from local to cloud side, it can improve the user experience by having more rendering resources. But this raises a higher requirement for the interconnection network between users and cloud. For example, we need a higher available and granted and sometimes flexible bandwidth. For example, larger than 1 gigabits per second, and sometimes lower latency. For example, smaller than 10 milliseconds, and lower jitter. For example, smaller than 5 milliseconds. So actually, optical network is very promising for this requirement. Next slide, please. This slide summarizes the requirement for optical network to access cloud. Optical networks with VPN can be used to to access multiple can be used for multiple cloud accessing. And actually, currently, some OTN equipment has already adopted the packet processing function, such as packet switching, MPLS, VPN, etc. Optical networks also have a high performance and high reliability. Also, smaller granularity container, for example, flexible. For example, with the flexibility of from 2 megabits to 1 gigabits per second is required to improve the efficiency of the network. Lastly, high bandwidth and low latency and low jitter are required for specific application like cloud VR. Next slide, please. So, and the last slide talks about the status and plan. Actually, in the other group, RTGWG has already have two useful related words: network to cloud gap analysis and network to cloud problem statement. I just presented this slide yesterday at RTGWG and get some feedback. And I think the content of this draft is complementary to the above work. Yesterday, I received the feedback that actually this work is very optical specific. So I am here to call for interest and join contribution from you. Thank you. I will stop here for comment and question.
Okay, thank you. Yeah, Sun. So I don't think we have enough time for detailed discussion. This draft, was presented in the routing area working group yesterday. So Haomian, could you quickly share the discussion to us?
Seeking for some common objectives with given to RTGWG document, but according to their feedback, it looks like we are having separated requirements with separated solution. Of course, the solution would be optical based, so it belongs to CCAMP, and this is just the kickoff of the new application work, and is still at the starting stage. And I will talk with Sheng and decide what to do in next step, probably with an evaluation on the gap analysis on what is the missing point for the current protocol stack, and we will report in next meeting. But we plan to switch the working group. Thank you.
Okay. If anyone has, more comments or questions, please take to the list. Okay, let's move to the next.
Okay. Can you hear me?
Yang? Yeah.
Yeah,
you
can you hear
only
me?
have three minutes. Yeah, we can hear. Yeah, go ahead.
3 minutes. Okay. This is a draft about semi-active WDM NBI, and it's from China Mobile and Huawei. Next page, please. Next page, please. Can you hear me? Okay. Firstly, I will introduce semi-active WDM quickly. The semi-active WDM is composed by passive part and active part. By the AAU side, there are colored optical models and also max and demax models. By the DU side, there is active WDM equipment. So we need to use a centralized management system to control the WDM equipment and the remote optical modules. So the management system can connect with the WDM equipment, but the remote optical modules cannot be connected directly. So we use an OEM channel to transmit the management and the control information between the remote optical modules and the WDM equipment. And the OEM channel can be realized by service signal overhead or by the pilot tone with the low modulation depth of the optical channel signals. Next page, please. Next page, please. So the semi-active WDM can not only greatly reduce the pressure of optical fiber resources, but also has the advantages in cost management and protection. The first one is semi-active system can support optical layer protection. The second one is semi-active WDM can support fault and performance monitoring. The last one is the remote optical modules can be also managed by the transport controller. And we have pushed the data plan schemes of the semi-active WDM in ITU, and some projects have been established. So we suggest to start the research about the management and NBI for semi-active WDM in IETF. Next page, please. So we think about what should be managed for semi-active WDM. By the local side, we should manage the WDM equipment and the card, the port, and so on. And in the remote side, we also need to manage the optical modules. And about the whole system, we manage the topology and the connections. So next page, please. I will introduce quickly. It is preferred the semi-active WDM system should be managed by the transport controller, including the local WDM equipment and the remote optical modules. And there are some existing models in IETF. We have listed here. Some of them are defined for WDM system. So we think maybe they can use for semi-active WDM, maybe not. So we think the extension for semi-active WDM is still an undergoing research. Next page, please. So next step, firstly, we will evaluate the existing models, and we should think about what need to be extended for semi-active WDM, and maybe we will give a detailed description or conclusion sometime later, maybe next meeting. So at last, we are glad to invite more people to join this work. That's all.
Okay, thank you. You already spent 3 more minutes. Yeah. So actually, I see a comment from Deborah, and he sent a comment in the chat window. She says, we should, separate data plan from the country plan. Yeah, I fully agree with her comment. So anyway, yeah. So actually, in CCAMP, we cannot define the data plan technologies. We just define the country plan stuff. And so we have to monitor the progress of the data plan in IETF 15. Yeah. Any comments? So actually, we don't have time for more comments. Yeah.
Okay, we just started this research, so maybe some detail or some discussion can email.
Lots of silence. Is the meeting concluded? I guess so. Yep, I see a see you from Fatai in the chat. Bye, everybody.
Bye bye. Thank you.